Alright, so today we're going to have a look at, an in-depth look at integration by substitution. Now, the textbook does integration by substitution in a strange way. I'm going to show you in my way, in the way that I prefer, and hopefully we like it better than the textbook. Now, talked about this before. Extension 1, you'll be given the substitution. Extension 2, you will not be given the substitution every time, and you'll have to figure out what would be best to substitute. Now, how do we integrate by substitution? Number 1 is we write the substitution to the right-hand side of the integral. Number 2, we differentiate our substitution, and we always write it in the form du is f dash of x dx, where f of x is our substitution. We substitute u and du into the integral, and two options. If it's a definite integral, if it's a definite integral, we're either going to change the bounds or we're going to substitute what u is back into our answer. That will all make sense soon. Alright, so we're going to find the integral of x, 1 minus x squared to the power of 4, using the substitution u is equal to 1 minus x squared. So to do this, we're going to write u is equal to 1 minus x squared. So du is minus 2x dx. Now what the textbook does is then it goes and divides this over to here, and it's a bit weird, and you substitute in dx. Personally, I prefer to do this. We want to substitute in minus 2x dx because we want to get rid of this dx and replace it with a du. If we don't do that, we can't integrate with respect to u, we can only integrate with respect to x. So what we need to do here is I want a 2x out the front. I actually want a minus 2x here. But the only way that's going to occur is if I multiply the integral by minus a half. Right. So now we've got minus 2x, 1 minus x squared to the power of 4 dx, and we're in the correct form now because this is du. So we can say this is minus a half times by the integral 1 minus x squared was u, so it's u to the power of 4 du. Now the integral of u to the power of 4 is u to the power of 5 on 5 plus c, and then we're just going to simply substitute in u back into the expression, so 1 minus x squared back into this. So minus a half times by 1 minus x squared to the power of 5 on 5, which is, bring that up to here, minus 1 minus x squared to the power of 5 on 10 plus c. Okay, question number 2. We're finding the integral of sine x root 1 minus cos x using the substitution u is equal to 1 minus cos x. So u is equal to 1 minus cos x, which means du is minus sine x, which is sine x dx. That's because the differentiation of cos x is minus sine x. Two minuses make a plus. Pardon me. Now we're in the correct form because I've got a sine x dx, which is now du, so I can say this is the integral. Now u was 1 minus cos x, so it's root u du. So this is the integral of u to the power of a half du. Now the integral of u to the power of half is 2 on 3, u to the 3 on 2. You should be all over that with advanced. So 2 on 3, 1 minus cos x to the power of 3 on 2 plus c, and we're done. Okay, we're going to find the integral of x root 1 minus x using the substitution u is 1 minus x. So u is equal to 1 minus x, which means du is minus dx, minus 1 dx. So this question's really quite a lot easier than the other ones because we don't have to do any manipulation. all we have to do is go, okay, the only way I'm going to get minus dx is if I had a minus 1 out here. So minus times by the integral of x, so we might put a minus here, root 1 minus x dx. So now this is du. But there's a problem here because u is 1 minus x. We don't know what just x is on its own. So we might say over to here that, well, x has to be 1 minus u. We rearrange that for x. X is 1 minus u. So we know that minus dx is du. So this is going to be minus the integral. X has become 1 minus u. And u is the square root of 1 minus x. So the square root of u, or u to the power of a half. Now if we expand that, it's going to be integral of u to the power of half minus u to the power of 3 on 2, and we might say du. Now if we integrate that, we're going to get minus 2 on 3, u to the 3 on 2, minus 2 on 5, u to the 5 on 2, plus c. Then we just have to substitute in our value and expand through that minus. So 2 on 5, 1 minus x to the 5 on 2, minus 2 on 3, 1 minus x to the power of 3 on 2 plus c. Alright, next one. We're going to find the integral of 2x on 1 plus x squared using the substitution u is 1 plus x squared. So u is equal to 1 plus x squared, which means du is 2x dx. Nice and easy one because we're in the right form. 2x dx is du. So we can say this is the integral of 1 over u squared. That's because u is 1 plus x squared. So 1 plus x squared would be u squared du, which is equal to the integral of u to the minus 2 du, which is minus u to the minus 1 plus c, which is minus 1 on u plus c. Now u is 1 plus x squared, so it's minus 1 on 1 plus x squared plus c. Alright, we need to find the integral in our next question of x cubed bracket x to the power of 4 plus 1 to the power of 5 using the substitution u is x to the power of 4 plus 1. So u is equal to x to the power of 4 plus 1, which means du is 4x cubed dx. Now, not quite in the right form because I've got an x cubed and I've got a dx, but I don't have a 4x cubed. So let's make it so we have a 4x cubed. 4x cubed, x to the power of 4 plus 1 to the power of 5 dx. But I need to put a 1 on 4 out here, otherwise we're not going to have 4x cubed because I have to times 4 by 1/4 to get our 1x cubed. Again, because I can't just randomly multiply an integral by 4. Now we're in the right form because this is du and we've got u there. So 1 on 4 times by the integral of u to the power of 5 du. So that's 1 on 4. The integral of u to the power of 5 is u to the power of 6 on 6. So this is, the u is x to the power of 4 plus 1. So x to the power of 4 plus 1 to the power of 6 over 4 times 6 is 24 plus c. Okay, now we're going to go into finding definite integrals using substitution. So we're finding the integral from 0 to 1 of 2x cubed on root 1 plus x to the power of 4 using the substitution u is 1 plus x to the power of 4. So if we write in our substitution u is equal to 1 plus x to the power of 4, well then du is equal to 4x cubed. Now that's not quite what we've got on the top. Again, we want to somehow substitute in this, we want to substitute in 4x cubed dx with du. The only way I'm going to be able to substitute in 4x cubed is if this was 4x cubed on the top. But I don't have that on the top, So I need to multiply the integral by a half, because then I would have my original 2x cubed on the top. Now I'm in the right form. So this is 1/2 the integral from 0 to 1. Now I've got a du on the top, because this here is du over u to the power of a half. Okay, now this is equal to, now the integral of u to the power of a half, well, that's the integral, I hate working across the page, but I ran out of room, u to the minus a half du, which is equal to a half times by 2u to the half. The integral of u to the minus half is 2u to the half. You should know that from advance, hopefully. So it's equal to a half times by 2 root 1 minus 0. So, oh, I've forgotten to do something, ignore me. So I've just made a mistake in terms of our bounds, which is why I personally don't like to do it this way. So before we can enter in our bounds, what we have to do is then replace our u. So we had u to the power of a half, but I can't just go and calculate that. I need to go and substitute back in my u. So 1/2 2 1 plus x to the power of 4, and that's to the power of a half. I might move this up here. And that's from 0 to 1, that's better. Now what you can also do, you hopefully maybe would have seen this in advance, if not I'll show it in a further example, is changing the bounds, which is what most people do. I personally prefer to do it this way. So we've got a half times by 2 root 2, I think. What's that? Substituting in 1, yeah, we get 2 root 2, and then 2 times by 1, so minus 2. Let me just quickly check if that's right. Yeah, okay. So from 0 to 1 is 2 root 2 minus 2. And then we could just say this is root 2 minus 1. Okay, find the following using the substitution u is equal to tan of x. So we don't have to just substitute in something in terms of just x, we can substitute in trigonometric functions, and we're going to look at that further later. So let u equal tan of x, which means du is equal to sec squared of x dx. And that's going to be really good because I've got sec squared of x on the top. So this is equal to the integral, and I might actually show you how to change the bounds in this example here. So number 1 is to substitute your u back into the question. Number 2 is to change the bounds. Both of them will get the same answer. So this is equal to, well, sec squared of x dx is du, and u is tan of x, so this is 1 on u. Let's have a look at changing the bounds. We know that, well, the bounds are normally from x is pi on 4 to x is pi on 3. And we want to know what the value of u is going to be at these points, because those are going to be our new bounds. We've entered in a substitution. So we're going to go, okay, u is equal to tan of x. So tan of pi on 4 is 1. And tan of pi on 3 is root 3. So my new bounds are from 1 to root 3. du. Now the integral of 1 on u is ln of u. So this is ln of u from 1 to root 3, which is ln of root 3 minus ln of 1. Now ln of 1 is 0, so the answer is the natural logarithm of root 3. Alright, thank you for listening.